I'm working on a solo game dev project called Sacred Forest, an open-world action-adventure game where you play as a pixel art bow-wielding heroine set within a vast forestscape. There's a lot of action, and you battle blight-infected monsters to bring balance to the forest. It's developed in Godot 4, and you can even wishlist it on Steam. I'll leave a link down below. First of all, since the last devlog, there are some good suggestions to implement for the character and my player camera. Since I previously made a non-clipping camera for my main character, a lot of people suggested making the character transparent when the camera is zoomed in. So I did that. I also made the character transparent when aiming your bow. That way you can see what you're aiming at, which, honestly, I had implemented this quite a while ago, but it broke when I added normal maps to all my pixel art characters, and I kinda just didn't notice that it wasn't working. But it's fixed now. Aside from the player, a big part of this month I've been pretty focused on trying to expand out the world of Sacred Forest, with my goal of eventually releasing a playable demo for the game. I've already made a small tutorial to give players a quick little introduction before letting them go off on their adventure. There is just one small little tiny minuscule microscopic minor thing, and that negligible trivial insignificant tidbit is that I haven't actually developed the adventure yet. I've said before that I want to expand outward from the beginning area of the game, at least just to start out with, so I can get a good sense of the scale of the world. For building more of the world, I went ahead and filled in this pathway that leads from the starting area and connects the first little village area. It is starting to look a little less bare, but you can think of most of what I'm showing off as a little more than a blockout with some details thrown in. I also added this little camp area up here. And to the left of this pathway is a small pine forest, which fills in the space between the tutorial section and the village. If I go through this small little forest area, I eventually get to the new lake area. I like the way the sun bounces off the water, and you get to see a cool little windmill in the distance. And yeah, I added this little windmill on the cliffside hill, which you can even go in and adjust the capstan to make the sails start turning and the gears start spinning. From there, it sort of wraps around the lake and goes back to the village. So I have this small connected chunk of the world made so far, and while it isn't anywhere near complete, especially because there are barely any NPCs and characters added in, it does make the game feel more like a game and less like a tech demo. Now, this piece of world is about the size that I would expect to be loaded in at any point in time as a player would move around the world. So it's a good measure of what the performance would look like if I built out the entire game with the same constant level of detail, but just use my zone loading system to only keep the surrounding chunks loaded in. This would be all well and good, but alas, the game runs pretty awful. Now, if I don't use my zone loading system, then I pretty much can't even edit the game world. It gets really laggy and kinda hard to just do anything, which I'm not even gonna go into how long it takes to load the editor for Godot and how long it takes to do a save. By assigning everything to zones to be loaded in, even in the editor, I'm at least able to make the game, and I could keep it just like this. I do have a pretty beefy B-puter, which does run it okay, even if it is a little older, but I would really like to have the game run well on something like a Steam Deck, so it needs a little something something to give it a bit of a boost. And it would be really nice if it ran smoothly when editing the game. So what do I do about it? Well, before I go through and optimize every mesh and material, which would probably solve all my problems, I wanted to see what features I could use within Godot first, since that wouldn't change the look of the game at all. I'm already using some of the easy ones like occlusion culling and level of details, but there are some techniques I wanted to explore to see if it would help out. I like to build out structures in the world using modular pieces because it makes it easy to design unique looking buildings depending on the area in the game without having to start from scratch every time. I know the conventional wisdom is to sometimes combine everything for a building into a single mesh so that it ends up only being a single draw call for the GPU. But I also know there are ways to batch things so it can reduce the draw call amount, and this is where I started my journey down the rabbit hole. A few devlogs ago, I showed off a little demo of rendering cubes in a world. In one test, I rendered cubes as separate mesh instance 3D nodes, and the other test was rendering the same amount of cubes but using one multi-mesh instance 3D node. The Mesh Instance 3D node version didn't run well, while the Multi-Mesh Instance 3D node version ran smoothly and could support way more cubes to render. I didn't know it at the time, but this was not a very good test. From the result, I was sort of under the wrong assumption that by using individual mesh instance 3D nodes, it would result in individual draw calls per node, because that's what it did during the test. If I run the same test, but use an actual mesh instead of instantiating cubes, you'll notice that I rendered a ton of these meshes, but the draw call count is still quite low. It doesn't really matter how many of these meshes I render, the draw call count stays about the same, and only really matters on what type of mesh are being rendered and what materials. So Godot is actually doing some batching for you to group draw calls by mesh and materials. It didn't do that in the cube test because even though they were all cubes, they were unique meshes and unique materials. So back to the way I build out structures. From that old cube test, I thought maybe it would be a good idea to convert all of my meshes into multi-mesh instance 3D nodes. So for example, every single floor in this building will be rendered by a single multi-mesh instance 3D node. I wrote a tool that can extract all of the meshes in a scene and group them into corresponding multi-mesh instance 3D nodes. Then I made a test scene, and in one test, I rendered all of the meshes as separate mesh instance 3D nodes, and then ran the same world, but with multi-mesh instance 3D nodes. And this is where things got a little disappointing and maybe a tad bit confusing. Now, for these tests, I left occlusion culling on, because it's a realistic scenario for my game, and I wanted to see if converting structures into their own multi-mesh would be worth it. I know that with a multi-mesh, you can only render everything or nothing without writing some script logic to control the instances, so occlusion culling is more difficult to take advantage of. Anyway, my result was that my test scene ran way better using individual mesh instance 3D nodes than grouping things into multi-mesh nodes. I kinda chalk this up to being able to occlude individual meshes rather than having to pretty much always render the entire multi-mesh. I did actually test this in my main game world as well, where I converted each structure into their own multi-mesh groups, and my result was pretty much the same as the test scene, where the individual mesh version ran a lot better and had consistently less draw calls and geometry rendered at any given time. So for modular buildings, it really seems like the way to go is to just continue building them with individual mesh instance 3D nodes, and letting Godot batch the draw calls. Now, this result had me questioning things pretty hard, because I'm using the Spatial Gardener plugin to paint foliage and trees and rocks and stuff, and under the hood it uses patches of multi-mesh instance 3D nodes. So, would it actually be better to render foliage as individual nodes, like I'm doing with the buildings? Well, since I've gone this far, I decided to test the main 3 ways to render objects. The 2 ways I've already talked about with mesh instance 3D nodes and multi-mesh instance 3D nodes. The other way is to just bypass the node system entirely and directly use the rendering server. Using the rendering server directly is interesting because it still lets you take advantage of individual occlusion culling, unlike multi-mesh instance 3D nodes, and it doesn't clog up the scene tree with tons of individual nodes. I wanted to mainly test this with grass foliage because that is the mesh that gets rendered the most. So I set up a test scene and rendered the same amount of grass but with all 3 methods, and measured the performance for each version individually. I gradually increased the total amount of grass in the scene to try to find at what point things fall apart. So here are my results. I wanted to stress test the grass until it caused a performance hit to only render at about 30 FPS. For using individual mesh instance 3D nodes, I dropped to about 30 FPS when rendering around 75,000 grass nodes. Using the rendering server directly, I didn't really get to render much more before the 30 FPS mark. It took about 80,000 grass instances, so I guess it is a small improvement. Now for both of these tests, I was able to improve the performance a bit by adjusting the visibility range, so that it would only render grass near the player, which is something the multi-mesh test won't be able to do the same way. Now for the final test, where I just use a multi-mesh instance 3D node. Well, I was able to render 5 million grass instances with just this single node before I hit the 30 FPS mark. Alright, so what does this all mean to me? Well, I think for things like foliage, I'm on the right path, and I'm just going to continue to use the Spatial Gardener plugin and take advantage of using multi-mesh nodes. For buildings and structures, where I might only have a few hundred nodes per zone, I think I'll just let Godot handle batching, and use individual mesh instance 3D nodes like I'm already doing to take advantage of occlusion culling and LODs. The rendering server option was interesting, but it doesn't really seem like it would be worth using unless there was a really specific use case, or if you wanted to switch to an ECS system, just because it does complicate how you spawn in and control things. Knowing all of that, it doesn't really fix my immediate performance issue. But hey, the more you know, the more you know. I'll probably just have to suck it up at some point and really optimize all of my meshes and materials to be more efficient. Anyway, if you have suggestions, I'd love to hear it. Also, I'll leave a link in the description with the multi-mesh extractor tool that I wrote and some of the test scripts for spawning things using all three methods of rendering. I'd like to say thanks to all my patrons, which I've actually started posting weekly updates about Sacred Forest. Also, you can check out the Steam page and join the Discord. Or not. Until next time.